Hey everyone, Mrs. Spatola. These are the answers from last night's homework. Take a look. And notice with problem number 2, just a reminder that when you have a variable, it's always a good idea to put a 1 in front of it so that you can use it as a number when you're combining your like terms. Remember, if you have any questions, please make sure you ask in class or you can ask in the Google Classroom. After number 7, we can slide down and let's take a look at these. Questions 8 and 9. We have some more comparing, are these pairs of expressions equivalent? And then question number 9, hint, hint, that looks like a great test question. All right, let's look at today's lesson. Today we're going to be looking at area models with some diagrams. Unit 6, Lesson 3, the distributive property area model. How can you use the distributive property with a variable? So let's take a look. It says, the do now says write an example of the distributive property, and that can be either with or without a variable. So I'm just going to choose, let's say 8. I'm going to clear that out, and I'll go to my pen. Let's try 8 times 2 plus 3. And remember, I could have as many numbers on the inside, as many terms as I want. And the important thing is to have the number on the outside so that when I distribute, I can apply it to the terms on the inside. Let's keep going. How can a diagram be used to demonstrate the distributive property? Well, in today's lesson, what we're going to be doing is using a diagram to help us. Here is a rectangle composed of 2 smaller rectangles, A and B. So if we take a look at the model given, we see that here's A, here's B. On one side, we have a length of 3. Then we have another length on the top of 2, and then an unknown, which is written as X. Based on the drawing, we can make several observations about the area of the rectangle. We're just going to read through this. One side length of the large rectangle is 3, and the other is 2 plus X. So its area is 3 times 2 plus X. Let's stop there for 1 minute and take a look at that. Let's back it up. So I notice that when these 2 rectangles are being combined, I have my 3 on the outside here, so there's my 3. And then I have at the top, I have the width of 2 plus another width of X. So I can apply it here, 2 plus X. And that's how I get the area of 3 times 2 plus X. But now we have to continue to solve. Since the large rectangle can be decomposed, what does decomposed mean? Decomposed. Decomposed means to break down. You may be hearing that a lot more in 7th grade or even in science. When something is decomposed, it is broken down. So since the large rectangle can be decomposed into 2 smaller rectangles, A and B, with no overlap, the area of the large rectangle is also, ready, the whole entire thing, is also the sum of the areas of rectangles A and B. So what it's saying is that they are equivalent. So if I go to rectangle A, if I wanted to calculate the area of just this rectangle A here, I could say that 3 times 2 is going to be the area, which is 6 square units. But then for letter B, I also can see that the length of this side here is 3. So in order to calculate the area, I could multiply 3 times x and get 3x. So what this is actually saying is that if I add the two areas together, 6 plus 3x, 6 plus 3x, that particular expression will be equal to this. That's all it's saying. And you might be thinking, well, that's an awful lot of work, and why do I need to do this? This will make more sense as we continue on to find the perimeter and the area of other shapes. This is just a basic lesson. So if I were to take this 6 plus 3x, and I look at this other one, 3 times 2 plus x, if I were to apply the distributive property to this particular expression here, they should be equal. That is what this is all about. Now let's go down to the bullet here. It says, since both expressions represent the area of the large rectangle, they are equivalent or equal to each other. So it's saying that 3 times 2 plus x is equivalent to 6 plus 3 times x. Well, if I just come back to the top, I can actually prove that. And of course, I can always switch the order. So what do I have? 6 plus 3x is equivalent to 3 times 2 plus 3 times x. So this turns out to be 6 plus 3x. Are they equivalent? They are. And that's basically the point of this entire thing, to show that if I take the areas broken apart, they are equivalent to the entire area of the entire large rectangle. We can kind of skip the rest of this for now. Let's go on to the next page and see some more diagrams. Partition rectangles when lengths are unknown. Number 1, here are two rectangles. The length and width of one rectangle are 8 and 5. The width of the other rectangle is 5, but its length is unknown, so we labeled it x. Write an expression for the sum of the areas of the two rectangles. So for the first one, they want you to write what the areas of each one would be, and then just add them together. So we can do this together. We can just go ahead and do this. This will be a modeled pretty much lesson. So for the first one, we have 5 times x because area is length times width. For the second one, we have 5 times 8. And we could add them together. So what would that look like? This would look like 5x because that's the area, and this would be 40. So it says write an expression for the sum of the areas. So what would it look like? 5x plus 40. Okay, so they're partitioned, they're broken apart, and basically the point of this page and the point of this exercise is to show that when we have two separate rectangles and then we have them put together, when we apply the distributive property, they will be equivalent or equal. Let's look at number 2. Number 2 says the two rectangles can be composed into one larger rectangle as shown below. What are the width and length of the new large rectangle? Or what is the width and length of the new large rectangle? So in this case, just like we saw on the model of the first page, all we have to do is basically combine and the new width and the new length, so it would be 5 times x plus 8. Number 3 says write an expression for the total area of the large rectangle as the product of its width and length. So all they want you to do for number 3 is apply the distributive property, and it would look like this. We would make it 5 times x plus 5 times 8. Final answer is 5x plus 40, which is the same as when they were separately apart at the top. And we just basically proved that they are equivalent. Okay, that's it for that page. Here is some practice. Number 1, here is a rectangle. Letter A, explain why the area of the large rectangle is 2a plus 3a plus 4a. And the next one should be letter B. Please make this letter B. It says, explain why the area of the large rectangle is A times 2 plus 3 plus 4. Okay, so take a minute and let's look. Well, let's look at letter A. The large rectangle, 2a plus 3a plus 4a. As we showed previously with the models, we can apply the distributive property, and we could see that the area of the first rectangle would be 2 times a, which is 2a. 2 times a, which is equal to 2a. The second one is 3 times a, which gets us a total of 3a. And lastly, we have 4 times a, which is the same as 4a. And when we have the models put together or combined, we can add them as 2a plus 3a plus 4a. So in words, explain why the large rectangle is 2a plus 3a plus 4a is because we can multiply the lengths of the widths, the lengths and the widths of the different rectangles and just add them. So put that in words in your own writing. Letter B, explain why the area of the large rectangle is A times 2 plus 3 plus 4. Well, if we take a look at that, hopefully you would recognize that the total, if I distribute A times 2 plus A times 3 plus A times 4, the reason why I can say that this is the area is because it is equal or equivalent to the same exact thing that we did in this problem. So we can just turn around and say that it is equivalent to the area in problem A. And we are going to stop there on this page. You do not have to do number 2, and you do not have to do number 3. For homework tonight, you're going to have more practice problems. So check the Google Classroom to see what page this is in your workbook. And that's it for today. So this is Mrs. Spatola reminding you to have a great day. And of course, always be kind.